Welcome to the session. Greeting of the day. In today's class, we are going to see about the various types of magnetic particles present, which are useful for doing the magnetic particle inspection. In previous classes, we have seen what is magnetic particle testing and the test procedures to conduct those inspection, to rectify or to find discontinuities and to do further repairing processes. After procedure, we have seen about these types of introducing the magnetic field. Some direct method, some indirect methods we have seen. In continuous with that, we go ahead. See, this is how we have first initially classified our non-destructive testing processes. That is, we have divided into two surface defects. On that, we are seeing about the magnetic particle inspections, and one more is the subsurface defects also available. So, in the most common NDT methods, we are as of now we are studying about the magnetic particle testing. Here, as of now, we have covered about the procedures and magnetic introduction of the magnetic field. But while introducing the magnetic field, by the test procedure, we are using some spraying of the particles over there. So definitely, those particles should have some ability or properties. And what are those particle types? We have some two types of dry particle types, or otherwise a wet particle type. That those things we are going to see now. See here, a particle characteristics which is used in the magnetic particle. So particle characteristics one by one we have to see. The particles used in magnetic particle testing MT are made up of finely divided ferromagnetic material. We know this. Magnetic particle testing process can be only done on the ferromagnetic material because as it wanted to do a magnetization. Therefore, it is unnecessary. Finally divided. Therefore, the particles which are sprayed also to be a ferromagnetic material. So that the particle should have some properties. They are number one, highly magnetic permeability, number two, low retentivity, and number three, some other factors are there. One by one we will see. We will take as number one. Here, magnetic characteristics I have taken as number one. High magnetic permeability. It is important because it makes the particle attracted easily to a small magnetic leakage fields from the discontinuity also. So we have heard this word permeability in casting. How far it is permitting this air, a hot gas which is generated from casting process to move outside through the porous sands. That is called as permeability. So here how we are telling this particle's permeability, this particle should move easily towards the gaps or micro gaps. If it is a micro gap, is the particle is very large, somehow it will not match, or somewhere it cannot able to fit into that cracks. So that is what it is given. It makes particles attract easily to small magnetic leakage fields also. Even very small leakage fields also, these particles can able to attract and join there. That much availability of permeability to be there to that ferromagnetic magnetic particles. Number two, about low retentivity. See, it is important again. All these three characters are important. It is important because the particles themselves never become strongly magnetized. It can able to. We need some. It is not strongly magnetized. We are doing some applying some magnetic field over there. Therefore, it is getting stronger, and it is attracted towards the discontinuity or attracted towards the gaps. So they do not stick to each other. They are attracted by the other magnetic field or surface on the surface of the parts. It means it should not repel. It should attract. It should strongly attract. Therefore, it should have some strong ability of attraction, strong ability of magnetizations. So this is about uh, high magnetic permeability and low retentivity. Low retentivity means it should not repel. Repulsion should not be there. That is why it is I am calling this a low retention property. Low repulsion properties. Low retentivity. At last, the third one. Some other properties are there of importance that affect the sensitivity of the magnetic particle testings. What are they? What is the size of the particles? Whether it is a large or it is very micro level, because this micro level only helpful to go inside the cracks at discontinuity. We have know this point. So crack will be available here at this point. So any something a particle which are available has to come and it has to fulfill here. Then only it is possible to we will get some visibility. So that size is one point, and how far it is shaped. Then about the density of the particle, how far it is mobility. It should not be very larger in weight. It should move smoothly and attracted. And visibility and the contrast of the particle, the color. Visibility and the colors may be green or red or any other colors should be contrast to that specific surface. So according to the surface, the color can vary. So these are one of the parts of the properties. So we have seen totally three. One is high permeability and a low. One is high permeability and one is low retentivity, and the others like shape, size, density, mobility, and visibility. Some contrast colors. With this understanding, we will get into the types of magnetic particles. See, so these magnetic particles I am dividing into two categories, such as the name itself says it's the dry magnetic particles and the wet magnetic particles. So the dry magnetic particles, the powder, ferromagnetic powder with those three properties, it should be in dry. At the same time, when we are using the wet magnetic particles, this ferromagnetic material it should be in the particle form with these three properties should be in wet. Wet suspended, which is to be easily flow through the material, and it is equally with spreaded over there. It is easier to inspect. But dry powder is not like that. Whenever the powder is forced over there, it will be falling over there and it is placed and it is sticked over there. But liquid is not there, it is having some flowability. So it will move over the surfaces. But powder is not like that. It will stick over. When you are pouring powder here, it sticks over here. When you are putting powder here, it sticks. When you are putting powder here, it sticks. So we have to pour powder around the specimen. Where is the crack, we don't know. Because that is our duty. An inspector want to find the defect on the specimen where it is available. Whether it is on the surface, whether it is on the subsurface, whether it is in the longitudinal direction, whether it is in the perpendicular direction. That's our duty to do. That is why dry powder having some advantages. At the same time, wet particles also have some advantages. One by one we will go ahead. Number one, I have taken as a dry particle inspections. For that dry particle inspections, we have taken the dry particles. Dry particles are primarily used for examination of the welds. Generally, we are using in welding castings. That is why it is same I am repeating in the industry, whether it may be a boiler plant or with aerospace, in a railway applications, anything we want to connect. Otherwise, it's a raw material. When we want to do connection, then obviously the welding involves. When we want to prepare the raw specimen, obviously the casting involves. When we are doing this both, we can't able to do the job 100%. By practice, it comes. but error also comes along with that. Therefore, we need inspection to find the discontinuity or to find the defects, and we should eliminate it. That is why the examples at all times we are taking welding castings, because it is the fabrication is used more. Weldings and castings where detection of discontinuity is lying slightly below the surface also. See, we can able to find, we know in general defects are possible to find on the liquid filter test inspections or matic particle inspections or on the surfaces, whether the discontinuity on the surfaces. But we are having the magnetic property is there. Therefore, if there is any crack available at this point, maybe on the subsurfaces, but upper part of the subsurface, near subsurface, we can able to tell that, use the word near subsurface. If it is a defect is at the last, not it is not near the subsurface. This is the surface where we are going to do inspection. From eye point is here. This is near subsurface, near surface. Subsurface is near to the surface. But when the defect is very depth, it is not possible to find. But when the crack is nearer to the surface, this matic particles which we are spraying over the surface of the top, it also attracted by this magnetic field of attraction, because it is very nearer. Therefore, it can able to attract. So therefore, magnetic particle is able to do inspection for both surface and also for subsurface inspections. Now we see. Therefore, discontinuity is lying slightly below the surface. Particles provided in powder form may be in red color. Maybe this may be this red color. In the picture I am taking also. Maybe in the black color, see, somehow dark color. Maybe in the yellow color, maybe light yellow colors. Maybe in the gray colors, maybe in the somehow the gray color. In any colors, it should be contrast. That's what our idea. It should be in contrast mode. That's it. Other than that, anything is okay for us. So it may be a red, black, or yellow, or green. Some should be dry and should be contrast to the surface. The magnetic particles, it contains some properties variations depending upon the size, shape, coating methods are all common. Magnetic properties or particle sizes or shapes or coating methods are similar in all colors. There is no differences. But only the color differences is there. We are not bothering about property, because the ferromatic material having those property only we are collecting. It have the same permeability, same retentivity, same size and shape and coating, all are common. These magnetizing properties all are common, but it only differs in color, as we need a contrast where we do a different type of colored materials. A choice of powder is then determined primarily by which a powder will have a best contrast. See, that point came here, which suits the best contrast and visibility. So based upon this, for these two, the colors are changed. The red, black, yellows are changed there. So that is what our better understanding. The best contrast and for visibility, and the degree of sensitivity design on the parts being examined. So some few advantages and limitations are there. You will see under semantic particle of dry methods, dry particles. Advantages we will see. Excellent for locating discontinuities which are slightly below the surface. So we told it is possible to do on two methods. Two methods means one is on the surface and on the subsurface. That comes here as a advantage. Next point, easy to use for any large objects, and also we have only probe, therefore it is portable also. What is large objects, any boiler plant, any aircraft, we are going directly with the probe as a portable component. We are going directly to the component in service also. Not a fabrication can be done as a part, multiple parts we fabricate and we will assemble. After assembling in service, if there is any defect occurs there, so at the time also we can able to go directly with a portable probe component to the large fabricated, large assembled setup, and we can do inspection there by applying the magnetic field and by applying the magnetic particles. So it is portable and also easily possible to the large objects. That's a good advantage. So the large objects and the portable. A good mobility, that is what? A portable, therefore it is directly related good mobility. So when we are using a half wave DC, so we have seen types of currents: DC current, alternating current, half wave rectified alternating current, full wave rectified alternating current. So maybe half wave direct current also is we are using, because when we are using the half wave rectified AC current, it is equaling the DC, because DC current goes straight without interruptions. But at the same time, AC having the cycle sinusoidals. Therefore, we are using rectifiers and filters to make it as straight, as equal to DC. So not as messy as like wet particles. You see, in the wet particles, usually we are using waters as a liquid form and we are sprinkling over the samples, and those entire areas will be messy means dirtiness will happen. Liquid will spray over there and a lot of troubles to clean again. So that is what some messy. Equipment usually in less expensive. Yes, we are using only probe and powders. So sometimes some equipments like pi gauges, magnetic field indicators will use, whether it is present or magnetized or demagnetized. So we have some magnetic field indicators presence and to find out presence and absence of magnetic fields. So these are some advantages. But at the same time, we have some few disadvantages also. It is not as sensitive as a wet method for a very fine and shallow cracks. You see, when the powders are spreaded onto the surface, it is sticking over a specific point because it is a solid. Even it is a particle, it is having some weight and solid. It is not having fluidity. But at the same time, wet particles having a fluidity and it can able to flow smoothly over the other zones, and therefore it can able to spread equally and find all the defects which are very fine also, and the defects also which are very shallow cracks also we can able to find. Therefore it is having some less sensitivity as compared to the wet particles. So that will become the advantage of wet particles. Then that point, same point will come there. You will see. Second point of disadvantages of dry magnetic particles: not easy to cover all surfaces properly, especially the irregular shapes and the larger parts. You see, that is why the point came. When it is on the irregular surfaces, even though the liquid particles can able to spread when it is filled, but at the powder form it is sticking over there. Therefore, irregular shapes are facing some difficulty by dry magnetic particles. Then slower than the wet particles? Yes, definitely. A large volume can be easily spread by water. We can go for inspection. But it is not like in the dry powder. We have to throw powder again. Large volume of powders are needed. Next, you see a difficult to adapt a automated test system. Yes, particles adapting a difficult something. It is a non-automated process of dry particle inspections. That's why it is some limitations are there for the dry magnetic particle. Now I am coming to the second one of wet magnetic particle inspection. We have seen now one as dry particles. Now I am coming as a wet particles. This is also having some similar disadvantages. You see, magnetic particles are supplied in wet suspensions such as water or oil. So that is good. You can able to spread easily over the specimen. That is okay. See, mantic particles are available in two forms. So maybe the normal visible mantic particles or maybe the fluorescent mantic particles. While these fluorescent mantic particles or can be inspected through black light. That was a UV light they called as a black light. So they use that to identify fluorescent light, some green color it will be visible. So when exposed to near ultraviolet light or otherwise it is a black light, a fluorescent dye coated magnetic particles glow with a highly visible yellow green colors. See at the left side image, see at the left side image you see we have some different contrast colors. It means here maybe the orange colors or green colors are there, which makes you good contrast visibility. That is what the point, same point we seen in the uh, dry mantic particles also. Okay, next. Fluorescent particles are particularly useful for corners or keyways or deep holes where the discontinuities are difficult to interpret or difficult to see. So we are not normal through visual eye. If it is not, we are coming for other type of this NDT inspections only when the cracks are not visible by the normal vision. Then only we are using the magnifiers, then only we are using the contrast colors, then only we are using some liquid filtrant pouring over there to generate the contrast. If it is possible to see by our normal eyes, there is no need of any, none of these equipments are not required. The cracks are micro, but these micro cracks are generating a stress creation point, and this leads to the failure. That is why we are in the intention to rectify those things. So there are two, one will be the visible, which are normal like colors will be visible, and one more is the fluorescent particles. So similarly here also we have some advantage disadvantages. You see, it is more sensitive, it is more sensitive than dry because the suspensions provide particles with more mobility, right? It is giving more mobility is there on the wet particles. Makes it possible for a smaller particle to use since dust adheres to the surface, contaminations are reduced or eliminated. When we are using this a wet magnetic particles, it means a powder, it is suspended on water and we are floating over the specimens. But sometimes it try to cleaning process also takes place there because it's water. It is spreading over the dust particles which are on the surfaces. Also, it will be smoothly cleaned out. Then obviously it is a good sign because cleaning makes the dust out. If the dust out, definitely the discontinuities are visible. Then the particles which are in ferromatic particles will be attracted by the fielded specimen. Definitely it is giving some contrast points. Then we easily find. That is how it is a good sign of a more sensitivity. Quickly and thoroughly covers all the surfaces of irregular shaped. In the dry particles we have seen irregular shapes are not possible as it is sticking over. Irregular shaped parts, large or small, even this magnetic particles are possible. It is the fastest and most thorough method for examination of a large number of small parts. Even it is a very fast method as it is liquid flowing over there, and also thoroughly covers because 100% of surfaces are fully covered by liquid easily, but in the powder form 100% of volume surfaces of the specimen have to be covered part by part by spraying the powder, but it is not like a water spraying on the surfaces. It is easier, wet method is easier than that of the dry method. Fourth point, it is easy to measure It is easy to measure and control the concentration of particles in the suspensions, which makes a uniformity and accurate reproducibility of the results. Yes, as because it is a common uniform particles are added every 200 ml of water will contain this much 10 grams of powder. We constantly add, uniformity will be there. Therefore, same accurate results also will come. It readily adaptable to any kind of automated examination. Also, we have seen on video in the procedure where on the component they are fixing and finding. So in this that method, they are getting automated the setups. It is a very good set. It is also having some disadvantages. You see, usually wet particles are reliable for finding discontinuous lying below the surface, and dry particles detect preciously. Yes, it is messy to work with when using the field testing. So it is measurements, it is a liquid. Lot of troubles will be there, spreading over here and there, and the face, entire face become dirty. Third point, a recirculation system is required to keep particles in suspensions. We have to keep on sending. Always there is a chance of drying of these liquids. Therefore, we have to recirculation systems. We have to keep some. We should 100% find it is completely filled on the specimen. It sometimes presents a post cleaning problem. So that is what the post cleaning problem leads to a messiness. That is how we understood this. Wet particles can adhere to the system. Either you have to clean or wash out. Something you have to do because it is already wet. These dry powders are sticking over there at a specific point, but wet particles are spreading over there, but it is already wet. Definitely it will stick over there on the specimens. For inspection purpose, uniform. After inspection, we have to clean. During cleaning, it may create some difficulties because of it is adhering over the specimens. So this is how some of the limitations are there for our magnetic particles. And as of now, we have covered two methods, such as magnetic particles of a dry method and of the wet methods. You see, we summarize here of this class that in the types of magnetic particles, we have seen about two methods. One is dry particles and one is the wet particle method. Both can be used to do the inspections, magnetic particle inspections. Here I would like to add one small video lecture which is taken from our Google only. You can see.
Non-destructive testing, magnetic particle inspection. The magnetic particle examination is an excellent method to investigate near-surface defects in ferromagnetic material. This video shows the basic principle and the practical procedure. The material tester gets the machine ready for use and inserts the test lead between the two poles of an electromagnet. Then she takes a bottle with a suspension of magnetic particles, turns on the electromagnet with a foot switch, and applies the suspension of magnetic particles onto the test piece. Already in daylight, dark lines are visible on the surface. The lines can be seen much better under ultraviolet light, and particularly well at darkening the daylight. The suspension contains pigments that cover the magnetic particles and fluoresce under ultraviolet light. The particles run off in areas free from defects, and they are attracted and clustered near defects. This workpiece shows a whole array of cracks. The basic principle is to magnetize a ferromagnetic workpiece parallel to its surface, as shown in the sectional view. If the workpiece is free from defects, the magnetic field lines run within the workpiece and parallel to its surface. In places of magnetic inhomogeneity, for instance near cracks, the magnetic field lines will locally leave the surface and a leakage field occurs. Now, if a suspension of ferromagnetic particles is applied onto the test piece surface, the magnetic particles will run off at defect-free areas. In places of leakage fields, the magnetic particles are attracted and clustered together, thus indicating the place of the defect. The method works best using a pigment which covers the magnetic particles and shows fluorescence under ultraviolet light. Even cracks can be detected that are not open to the surface but just below it, as long as they are not too far below the surface. But one precondition must always be fulfilled. The magnetic field lines must be perpendicular, or at least at a certain angle to the defect. Otherwise there will be no leakage field and the defects remain undetected. Our test sample has been magnetized in horizontal direction. The magnetic field lines run horizontally. This is the reason why cracks in vertical direction are visible particularly well. To make sure to detect all near-surface cracks, one has to magnetize the sample once more and best perpendicularly to the first time. To do this, the material tester switches the machine over to the current flow method. A high electric current flows through the sample, generating a circular magnetic field. Now the cracks in horizontal direction can be seen very well. The tested sample is a hardened sliding guide. The cracks have been formed during the hardening process and the subsequent grinding operation. Still another test piece has to face the magnetic particle inspection, a section of a large gear wheel. The same procedure again. Placing the gear wheel between the magnetic pole pieces, magnetizing and applying magnetic particle suspension. Already in daylight there are indications of cracks, and again they are best visible under ultraviolet light while darkening the daylight. The visible cracks are so-called fatigue cracks. They have been generated during the operation of the gear drive due to a mismatch of the gear wheels.
We have seen a small YouTube clip.
Non-destructive
I
testing.
found it very
Magnetic
useful.
particle inspection.
The grid goes to
The magnetic particle examination is an excellent method to investigate near-surface defects in
the grid goes to the YouTube creator. We end up this class from here. In the remaining part of the subjects, we'll see you in